Hi, I'm Joe Norman. I'm a Partner Solutions Architect at AWS, and I'm here with Pooja Mehta, a Product Manager from Slack. We'll be talking today about getting started with cross-account encryption using AWS KMS and featuring Slack's new Enterprise Key Management. Starting with a little bit of a review of defense and encryption in AWS. Let's say you're a user in an EC2 instance or a Lambda function and you want to access documents or objects in S3. For the sake of this example. And our defense is multi-layered, kind of like a parfait. So at the first layer is the user object itself. That user is protected with a password or a key pair, as well as optional multi-factor authentication, which we recommend using. At the next layer is AWS Identity and Access Management, where you define a role that defines the rights to the services and the actions within those services that the user can access when that user is attached to the role. And then the next layer is at the networking layer. So you have the concept of an S3 VPC endpoint. So if that EC2 server is within a VPC or the Lambda function is within a VPC, you can set it up so it can only access S3 via the VPC endpoint. And with this VPC endpoint, you define an endpoint policy that controls what specific buckets can be accessed, which users can access it, which roles can access it. And it doesn't replace other policies in this chain of defenses, but it's vital at this layer. The next layer is the S3 bucket policy, which is attached to the S3 bucket itself. And that, kind of like the VPC endpoint policy, controls who can access it and how they can access it, but it also allows you to control things like making it so only access is enabled through that VPC endpoint. So you always want this in place as well. And finally, we have AWS KMS, which is our key management service. And that allows you to create a key policy on an encryption key that controls access to that key, and that key is then used to encrypt and decrypt the objects you store in S3. And since we're talking about S3, there's also other methods outside of KMS that are available, such as server-side encryption S3, but we're not going to dive into that in this presentation. KMS will be the focus of this presentation, and we'll dive a little bit deeper into that. And at that point, you have access to the documents and objects themselves. So moving on into a little more depth in KMS. KMS allows you to control the use of encryption across a wide range of AWS services in your applications. KMS is in many ways a silent hero behind the scenes of many AWS services, playing a vital support role. Starting with the left side of this diagram, clients access various AWS services and initiate encryption from those services. And it could also be an application within AWS using the SDKs. So it doesn't necessarily have to be an AWS service itself. Those services in turn access KMS to handle their encryption. So KMS kind of sits behind the scenes of these, doing the encryption for all these services as well as your application. KMS uses some of those services itself for its own support. So for example, AWS Identity and Access policies on individual master keys. And we'll dive a little bit into master keys later in the presentation. AWS Cloud Trail handles the logs for action. Any action taken against that customer master key is logged in AWS Cloud Trail. And then those logs are stored in Amazon S3 as well. And S3 also allows you to put versioning and deletion protection on those log files so you know they're secure. AWS KMS is integrated with lots of AWS services. At last count, I think it's somewhere around 45. I haven't counted this slide. EC2 on compute and storage, Amazon S3, and databases, Amazon Aurora. And analytics, we have Elasticsearch service. Machine learning, we have Amazon Comprehend. And Comprehend's a good example to step into because it is one service, you see the asterisk on it, that actually requires you to use service managed master keys. And we'll talk about that a little later in the presentation, what that means exactly. It doesn't allow you to do a customer managed master key. Application services, we got migration and transfer services like Snowball and Snowball Edge, developer tools like Cloud9, management tools like CloudWatch Logs, and kind of skipping ahead a little, we've got Workmail, Alexa for business owners. So it's a good number of AWS services, and as KMS is kind of that behind the scenes hero for it, it's important that these services are integrated with KMS. So 2 approaches to managing your keys. First, we kind of mentioned that when we talked about Comprehend on the last slide. The first is AWS Managed Master Keys, and this is the one where services like Comprehend require it. In other cases, it's optional to use either one of these paths. So AWS Managed Master Keys are an option that allow AWS itself to manage the rotation and the management activities for you. So you give up some control over your management of keys, like key rotation and key deletion, in exchange for AWS handling all the best practices for you. The other type of key is a customer managed master key, and this will be the focus of the presentation going forward. You can create and manage the master keys yourself, including things like rotation and disabling. So those become your task to manage. So you can automate key rotation. You choose which keys each service uses. So you create master keys, and when you make applications AWS or make buckets, for example, you can choose the master key that they use. You can also import your own key material as an option. Doing this can come in handy if you want to do something like control the source of key entropy. It also allows you to instantly delete a key, and that can come in handy when, for example, you want to control the time when AWS has access to your key. So say you only want AWS itself to have access to your master key when you're encrypting and decrypting, and never at any other time. Because you can never export keys from KMS, this ability to import your own key allows you to store that key material on your own hardware separately, and then import it into KMS when you want it and delete it instantly when you don't want AWS to have it. As far as all the operational aspects like security, latency, the durability, availability, and auditability, these two types of keys are exactly the same. A new feature that we announced at reInvent in November 2018 is AWS KMS custom key store using Cloud HSM. So as of reInvent, the Cloud HSM is integrated with the KMS API. Both methods here, whether you're managing your keys in KMS itself or within Cloud HSM, use the same FIPS 140-2 validated hardware security modules. Difference here is that KMS is validated at level 2 with level 3 in multiple categories, whereas Cloud HSM is level 3 overall. You might also want to use this integration when you require single tenant HSM or direct control of your HSM. And you might also need the ability to immediately remove material from KMS and independently prove that you've done so. And finally, you might want to do this if you want to independently audit KMS outside of KMS itself and outside of Cloud Trail. So that Cloud HSM service has its own auditability within the HSM module that you'll have access to. But as far as functionality, you're able to use the KMS API, and these function exactly the same. So for the purpose of the solution we're discussing here, you're absolutely free to use the Cloud HSM integration. So starting to dive a little more into the 200 level of this. So in KMS, there's a key hierarchy. KMS itself manages at the top of this diagram the customer master key in red. The customer master key, or CMK, is what does the encryption and decryption of keys. You can also encrypt and decrypt data with it, but for the purposes of envelope encryption, which we'll dive into a little bit more, usually you're creating keys, encrypting and decrypting those data keys, which are the green keys here. So the CMK manages keys and creates, encrypts, and decrypts keys. Data keys encrypt and decrypt data. And we'll dive into exactly how that's done on the next slide. Some advantages of this are that it enables envelope encryption, which avoids you having to manage the data keys. So you can make thousands of data keys, millions of data keys, and only have as few as one customer master key to managing KMS for that. The encrypted data keys can be stored together with the encrypted objects, so you never really have to keep track of what key is used to manage what object of data. So anytime you want to decrypt that data, you just send the data itself together with the key that it's stored with to KMS, and KMS will be able to decrypt that if you have the right level of access. It's also well suited to encrypting large data objects. So you're only sending that data key, which is a relatively small file, back and forth to KMS, to and from KMS, rather than sending, say, a multi-gigabyte file to KMS. And because of that, you're able to do much higher I/O, much less throughput, and do things more quickly, more efficiently. And finally, you're able to cache those data keys if you have high I/O operations. Say you need to encrypt or decrypt 1,000 objects really quickly. Rather than making 1,000 API calls to KMS, you're only having to make the one to decrypt the data key, and then you're able to store in memory that decrypted data key and do all your encryption and decryption objects when you need to do it, and then delete it when you don't need it anymore. Decrypt the plain text one when you don't need it. It'll be a little more clear on the next slide. So I've talked a lot about envelope encryption. Here's an example of it. In the example here, the context is S3 server-side encryption, but this can be applied to anything like application encryption, any other AWS services. They're using envelope encryption, which we'll demonstrate now. So first, let's say you start with plain text data. You send that to S3, which then needs to encrypt the data. So S3 is going to make a request to KMS to generate a new data key. We talked about data keys and master keys. KMS itself is going to look at that customer master key, check its key policy that S3 has access to that master key, and then return to S3 a data key for the specific object, a copy of that both encrypted and plain text. S3 is going to take the plain text version and encrypt the data with it, and it's going to delete the plain text version and store the encrypted copy with the data in the S3 bucket. That's the encryption side. Now moving on to the decryption side, when you want to open that object. So S3's got the encrypted object and the encrypted key, wants to decrypt it now. It's going to send the encrypted key only, not the data itself, to KMS. And then KMS is going to check its policy, make sure S3 still has access, and send the data key back to S3. And then with that plain text data key, S3 will be able to decrypt the object, and you'll be able to read the plain text data. Now moving into what this presentation is really about. Up till now, we've been in a very walled garden with this, keeping everything visible within your own AWS account. That's not really how the real world works. So I mean, up till now, you can see everything in your AWS account here. I've got multiple logos here. I think this is EC2, just a database, and Lambda within a VPC. It can be anything within your VPC. The idea here, though, is that the customer controls everything. The customer, or you, whoever you are, whether you're the customer or a partner or service provider, you have full visibility on the KMS and onto the services. But in the real world, companies are using things like SaaS. And we're using SaaS, for example, here. It could be other things like managed services and any sort of thing. But SaaS makes it for a straightforward example for the sake of this presentation. So when you talk about SaaS, you're sending your data into a third party's ecosystem without knowing what happens inside. So the SaaS provider controls everything, including the keys used to encrypt and decrypt data. So let's say you wanted to remove a SaaS access to data that you've put into it. You have to request that to the SaaS, but you don't have the ability to enforce that. It's a request rather than a demand, rather than an action you're taking. Diving into the SaaS side themselves, they're really just doing envelope encryption on their side. So customer has data, sends it over TLS to the SaaS or through some other form of encryption to the SaaS. So they've got your plain text data, just like with that server-side encryption S3, they're creating a data key, both plain text and encrypted. They're using the plain text key to encrypt the data, and then they're storing those together within their AWS account or wherever they're storing it. So how can we open that up to give the customer more control over what just happened? So what if we put the customer master key inside the customer account? Can we give the SaaS provider access to that? Well, sure. So the client, your users are going to put data in the SaaS, however you do that. From there, the SaaS provider can make a generate data key request, just like would happen in your own account, but this is a cross-account access. And we'll dive into the key policy required for this in the next slides. So makes that request, your customer account can send the data to the SaaS, send the data key and the encrypted data key to the SaaS, and then the SaaS takes over from there, using that plain text key to encrypt the data, caching that plain text key if necessary for any amount of time, then deleting it and storing the encrypted data key together with the encrypted data. When it comes to decryption, just sends a decrypt request over to your customer master key. You check your key policy to make sure it has the right to do this. And then if so, you're going to create a plain text data key and send it right back to the SaaS, who can then decrypt the data. So as far as key policies, how do you allow what we just saw? So this is really just a JSON. This key policy is attached to a customer master key. So you'd have one of these four per customer master key. And this is an example of a key policy that allows two different AWS accounts other than yours, assume other than yours, so this all ones and all two example AWS account, which I'll highlight in a second, will allow access to it. So the first thing I want to highlight is the effect field that can be allow or deny, and allow does what it says, it allows access, and deny revokes access to resources. Next is the principal. So these are your external AWS accounts. So for example, that SaaS in the last diagram, that would be their AWS accounts here, whatever they provide to you, the customer, or if you're the SaaS, what you're providing to your customer to get access to this KMS customer master key. The actions here define what are allowed or denied. So in the case of the last example, we were allowing the SaaS to make a call to generate data key when it was making that data key, and then to decrypt, which was when it needed to send back the encrypted data key to the customer and get back the plain text one. And last, we have the resource, which in the case of KMS key policies, the asterisk here just means it applies to the key that the policy is attached to. Now, watch the last two characters of this real quick. Now, let's say we want to revoke permissions. So we just add a new statement. So the statement field is an array. What we just went through was a statement allowing. So we're going to add to this policy a statement denying access to specific things. So for example, we want to revoke the SaaS's access to just one folder that's one folder of the data that's been stored. So starting out, we do a new statement with the effect of deny. So we're going to deny permissions. We're using the same principle, so we'll skip over that, just the two AWS accounts. And one thing I should mention on these AWS accounts is that you'll see the root there at the end of it. That actually just applies to every user in that AWS account, not just root in the case of key policies. So the action here are the same actions as before: generate data key and decrypt. You might ask, why do we need to stop generate data key if we're just blocking access to decrypt? Well, you also potentially want to not allow users to put new data in that same folder and have the SaaS be able to cache the data key for that new data and read it in the meantime. You might want to throw an error, but that's optional, the generate data key piece. But really what we're looking at is the decrypt is the more important piece of this. So you're removing that access. Resource is the same, but here is a new field. We've got condition. So here we're comparing an encryption context key value pair. So we've got folder home as this example. The encryption context is something in a key policy that is a set of key value pairs. It's data that you're free as the person creating the data key to enter really whatever you want. And the idea of encryption context is when you create the data key, you put encryption context with it, and then when you decrypt that data key later, you send an encryption context, and it needs to match the original encryption context, or KMS won't allow you to get a plain text data key from it. So in this case, we're only looking for keys where the folder encryption context had a value of home. And that'll be a little more clear later in the presentation when Slack takes over. They're doing some interesting things with encryption context, but this is really one of the cooler features that allows you to get granular with key revocation. And then moving back in KMS in general. So this is going to be especially important if you're allowing third parties to access your CMKs. KMS is integrated with AWS Cloud Trail, where every action taken against a CMK, like those generate data key calls and the decrypt calls, are logged to Cloud Trail, and that would be on the customer side of that diagram. So if a SaaS is requesting access to a customer CMK, then the customer gets these logs stored. So you'll see every time a request is made, and some of the fields that get stored in those Cloud Trail logs are the event name, so what APIs were called, the date time that it was done, the parameters for it, so what key exactly was taken action against, all those encryption context fields that we talked about briefly on the last slide, the IP address it came from, and the user identity and account number that the request came from. So you'll have full visibility into all of that with AWS Cloud Trail. And then finally, for my part of the presentation, I want to talk about a few challenges with this architecture that should be considered. So first, KMS is a regional service. So a request has to come from a call from the same region that the CMK exists in. You can't, so if you think about the AWS console, you set your region when you're setting up your console and your config. So that region needs to match the region of the CMK, and it will not allow decryption across regions. That's not to say that you can't physically be located in another region and just set your region to whatever you want. But if you have your region set to, for example, US East 1, the CMK has to be in US East 1. So if you need to use multiple regions, you'll need to manage multiple customer master keys. Next, so while we're eliminating some of the need for trust of a third party here, you still do need to trust that your SaaS is actually deleting those plain text data keys that get sent with the generate data key request. They do need the plain text data keys to decrypt the data, but after they get it, you lose visibility on the customer side of what it's done with that plain text data key. So one way this could be handled is things like third-party audits. This is an issue that's been dealt with in technology in general, but it's something to be aware of. And finally, on looking at the shared responsibility model, when you use a SaaS in general, you're giving a lot of control to the SaaS, and with that control comes things like trusting them to follow best practices around key management, so access control, key rotation, auditing. You can often assume that they're following the best practices there, and that may come with compliance certifications, things like that. In this case, if you're taking over control of your customer master key, you're taking back some of that control, and now it falls on you, the customer, to make sure you're following the right practices as far as access control to keys, the rotation of them, auditing those logs, and that all falls on you now. And now that's it from my part. Now I'm going to pass it on to Pooja at Slack to talk about enterprise key management.
Thanks, Joe. And as Joe mentioned at the beginning of this webinar, my name is Pooja Mehta, and I'm an enterprise product manager here at Slack. I'm here today to speak about Slack Enterprise Key Management, or Slack EKM, a new security feature that we released earlier this year. But before jumping into Slack EKM, I want to take a step back and provide an overview of Slack in case you're not familiar with the product. Our mission at Slack is to make our customers' working life simpler, more pleasant, and more productive. As such, we believe that Slack helps people work together and collaborate as easily online as they're able to do in person. The information, conversations, and software that teams use to get work done are all centralized in one place in Slack, making it faster and easier to get things done and thereby allowing your teams to become more agile. In the modern workplace, teams are often spread across various geographical locations, working with a number of different stakeholders, both internal and external to an organization, and using a variety of different tools in order to get their work done. This creates a false trade-off for many organizations who believe that it may not be possible to equally balance security and agility within the modern workplace. However, we here at Slack believe that it is possible to strike the right balance between staying secure and being agile. So let's take some time to dive into that. Here at Slack, we have built security into the product with building blocks that give IT admins and security professionals the control and visibility they need to manage all their security challenges, such as those associated to external team management and data transparency without compromising agility. Let's talk a little bit more detail about the building blocks that Slack provides in order to support this mission. While I could take the time to drill into every single one of these blocks here, I think that might quickly get overwhelming. So Slack offers more security capabilities than we can review in the time that we have today. So I'm just going to simply touch on the high-level categories going from left to right. First up are compliance and certifications block. These are an important part of our security program. At Slack, we pay rigorous attention to security standards. Our security program serves the needs of our customers by following standards serving a wide range of industries, from finance to healthcare to government. As our customer base continues to expand, we're continually rising the bar and expanding the scope of the compliance certificates that we support. The next block is around identification and authentication, and we offer a wide variety of features in this bucket. Identity management is likely the cornerstone of every IT team's responsibilities. Slack lets you pick from more or less automated options based on your organization's need in order to ensure that only the right people are able to log into your Slack environment. The third bucket here is around audit and accountability. Within this bucket, Slack offers features to keep you connected to how your organization is using Slack. For example, our audit logs capabilities let you see who is doing what and when in your Slack workspaces. And our data loss prevention integrations let you dynamically monitor for and act on information promptly that has been improperly shared in Slack. And the last bucket around access control. Slack gives you access control features that let you manage the security of your Slack data in every context. We provide easy to use and secure defaults and tools that you would expect from a well-secured cloud service. I hope that overview gives you a taste of the breadth and depth of capabilities that Slack offers from a security perspective. And with that, I want to dive into our newest feature under access control, Slack Enterprise Key Management, or as short known as Slack EKM. As mentioned earlier, we launched Slack EKM earlier this year. EKM augments Slack's existing security posture by allowing customers to manage their own encryption keys while ensuring Slack remains Slack from a usability perspective. In the event of a threat, admins can revoke access to their content in a very granular way. They are able to access or revoke access at the org level, the workspace level, channel, or even time frame. This granular control ensures that employees can continue working with the information they have access to, while admins have the peace of mind and control to mitigate any threat. When our team approached building Slack EKM as a solution, we evaluated a number of different options. So I want to take a moment just to kind of walk you through the spectrum of options that we evaluated before landing on the one that we went forward with. The first option on the left here is end-to-end encryption. In this option, data is encrypted and decrypted on the client before transferring to Slack servers. The pro here is that there's no operational access to data on the Slack side, and we minimize collateral data exposure. However, on the downside, search becomes a lookup. AI, ML, and fuzzy logic no longer would work. Apps would be able to write, but would not be able to read, and functionalities such as app mentions and link unfurling would no longer work. In summary, Slack would become a lightweight messaging tool and cease to support some of the advanced workflows and team collaboration capabilities that our customers rely on. On the other end of the spectrum, we evaluated a second option around a strong box approach. This option entails policy controls accompanied by operational tooling. The upside here was that we would reduce operational access to data and we'd be able to preserve all Slack functionality. However, on the downside, Slack would continue to maintain encryption keys and technical access to data for operational use, and there would be no cryptographic separation between customers. So in summary, policy-only controls allow Slack to be Slack, but offers no cryptographic security for our customers, which was a requirement. And that's where we landed on our approach, which balances both security and usability. In this option, customers have cryptographic control over which provides visibility and the opportunity for key revocation if necessary. The upside with this option is that we minimize operational access to data, minimize collateral data exposure, provide visibility into when and why data is decrypted, and offer customers the ability to revoke Slack's access to data, all while preserving the Slack that our customers know and love. Our approach is unique to others in the market because Slack remains Slack, and we provide our customers with the granularity and control of being able to revoke key access at various different levels, allowing work to continue happening within the environment. So now that I've shared a few of the different options that we evaluated before building Slack EKM, I want to take a moment to highlight the benefits of the feature based on the approach that we took. The first benefit around visibility at every step. Slack gives our customers visibility in how their keys are being accessed to encrypt and decrypt their messages and files in Slack. This information is logged in AWS KMS's CloudWatch and Cloud Trail logs, and these logs cannot be tampered, so the customer has the assurance that they have complete visibility on their end. The second benefit is that customers have the ability to respond to threats in a very granular manner, with the ability to revoke key access at the org, workspace, channel, timeframe, and file level. Which leads to the third benefit. Users can continue collaborating in Slack to keep work moving forward with the data they still have access to, even in the event of a threat. Since we've launched Slack EKM earlier this year, a number of our largest, most security-conscious customers have already begun reaping the benefits of this feature. This is a quote from the Chief Operating Officer at CrowdStrike, illustrating the importance of Slack EKM to their organization. With that, I want to spend the next several minutes diving into the Slack EKM architecture and show how AWS fits into this new world. In order to level set, I want to start by going through a simple illustration of how Slack encryption works today without Slack EKM. Let's imagine a user types a message into Slack, and let's assume the message is "Hello World." That message is encrypted, in transit and at rest, and stored in plain text in our MySQL database. Now let's see how this flow would change with the introduction of Slack EKM. First off, we would have two additional components to the architecture diagram. The first is the Slack EKM service, and the second is the customer's instance of AWS KMS. Similar to the previous example, let's assume a user types a message into Slack. For consistency, we'll use "Hello World." The message, along with the key scopes, are sent to the EKM service. EKM sends the key scope to KMS. The message data keys are then generated and scoped by KMS and wrapped by their unique combination of org, workspace, channel, and hour. The KMS logs an entry atomically into Cloud Trail, and for context, Cloud Trail logs every AWS API request, including the generate data key and the decrypt request from Slack that Slack makes to KMS. KMS sends the data key to the EKM service. The EKM service encrypts the message and persists the data key in memory for 5 minutes for performance of future encryption events. The data key and the reason code are then sent to CloudWatch. And again, for context, CloudWatch logs include key cache hits that never appear in AWS Cloud Trail because they never prompt requests to AWS KMS. The CloudWatch logs also include reason codes for why Slack makes these encrypt and decrypt requests. After this, the EKM service sends the encrypted message in ciphertext and the encrypted data key in ciphertext to Slack. And the message and key ciphertext are stored in the encrypted database. Great, now that we've gone through the encryption flow, let's quickly walk through what this flow looks like from a decryption perspective. All the components are largely the same, and there are no net new components in this flow. So let's assume a user logs into Slack and attempts to read a message that is currently in ciphertext and stored in our database. The ciphertext blob is sent to the EKM service along with enough metadata information so that the EKM service knows what keyscopes are needed to decrypt the message. The EKM service makes a request with the necessary keyscopes to KMS, and KMS produces a scoped data key from the CMK. KMS logs an entry atomically into Cloud Trail, just as it did as part of the encrypt flow. And KMS sends the data key to the EKM service. The EKM service decrypts the message and persists the data key in memory for 5 minutes, again for performance reasons. And the data key and reason code are also sent to CloudWatch. Finally, the decrypted message is then shown to the user. So as you saw over the last couple of slides, we broke down the architecture pretty granularly just to illustrate everything that goes into the encrypt and decrypt flows with the introduction of Slack EKM. However, there is a key important takeaway, and that is that while there's a lot of additional steps in these flows with the introduction of EKM, performance doesn't take a hit as a result of this. From an end user perspective, Slack continues to work just as quickly with EKM as it did without. In summary, Slack EKM With Slack EKM, Slack administrators get complete visibility and control over their data in Slack using their own encryption keys. This allows our customers to meet their security objectives without losing the Slack that they know and love. And with that, I'm going to pass it back to Joe.
Thanks, Pooja. Just want to thank everybody for listening to this webinar. And thank you on behalf of me at AWS and Pooja at Slack. Hopefully you learned something. If you're a SaaS provider or other provider, learn something you can go build for your customers. If you're a customer, you've got something you can think about with your partners that you work with. So it looks like we have a little bit of time for Q&A, so we'll move right into that now.